So it looks like the end of next week is exam.
Yeah. So still, I realized that you guys have sent email to Brother Bennett. I didn't respond yet.
Yeah. I think I'm gonna give him a phone call if I can find that number.
Okay,
But otherwise, if we just simply can't get hold of him, then we're just going to continue with our project.
Okay.
Without the approval, because we have to get it done. So. But so lesson 21 is our group project, and then lesson 22 is the group exam quiz. So what we should do is just do lesson 11 or 21, and then maybe we'll meet another time, or we'll go now finish 22 or something like that.
Okay.
Collaboration. Or maybe, sorry, lesson 23 is what I meant to say.
Yeah.
Collaboration group meeting quiz. Okay, so lesson 23. Just burn through this real fast. Okay, the true linear regression equation is this, where BO and B1 are unknown. What are the null and alternative hypothesis for B1? Okay, I'm going to need to take a look at this for a minute.
Yeah. So I'll say this, the third one. I'll go for the third one.
You go for a third?
Yes.
All right.
So when you open to the manual, the summary, you can see the appropriate hypothesis. These tests are the null B1 equal to 0, and the alternative is B1 is not equal to 0.
Yep. I see that in the summary. Yep. Okay, I agree. So number 4, the residual. Residuals. Difference between the observed value of y and the value that would have been predicted by the regression line.
Yeah. So,
Do the third one.
yes.
A plot of residuals supports using linear regression when let's see, a plot of residuals. Linear relationship. A plot of residual supports using linear regression. I'm looking.
We're just looking at.
Make what is called these regions. Presents the residuals for each value of it.
So I think it should be normally distributed. So can you, when you go to
Morning, brethren.
Hey, you guys.
I'm good. Sorry, I'm at a different house, so I had to get a Wi-Fi password so I can log in.
That's all right.
yeah.
We're just working on the lesson 23 quiz.
Okay. I'm heading there right now.
So when you open to the manual, 3.4 QQ plot of the residuals. It says something over there. Once the residual has been calculated in SPSS, we can assess if they are normally distributed using QQ plot. We simply make QQ plot of the residuals. If the point in the QQ plot are close to the line, then we can conclude that the residuals are normally
Okay, so you think it's normally distributed, the first one?
yeah.
Okay. I don't know for sure, but I'll go with that. Okay, number 6. Compute the residuals for the data using software. What statement best describes the residuals? All right, we need that data.
A residual is the difference between
Yeah, if you're looking at question 3, then we're looking at not equal to. So
no,
I think
wait, you guys are looking at
question 4.
No, I'm looking at question 4 is the third option, right? No.
Yes. The third option.
Yeah. Cool. 5. A plot of residual support using the regression one. Huh. Don't know that one.
we have 2 and 4. So we need to put this data in. Linear regression. The next 8, get the residual.
Do you have any spreadsheet, especially for this topic?
I think it's inference. 1 second, let me see. I was using it yesterday to do this thing. Document. Quantitative inference procedures.
Yeah. The last tab, linear regression.
Sorry about the noise in the background. I'm looking for my headphones as I speak. Okay.
So now, which one represents the B one? Okay, which one represents the B1?
I'm not sure about that.
Wait, what number are you guys on?
Okay, number 6.
Number 6, okay. I use the definition, use a confidence variable, estimator variable, and the score variable as a response. Let me grab my notepad. All right, let's see. I'm putting my data in this stuff so I can.
Compute the residuals. Variable entity.
The score variable as a response. So score is y. So just a quick question on this one. You guys know the score is y and the confidence rating is x, right?
Yeah.
Okay, because that was one of the mistakes we made on the last one. That's why I'm double checking if you guys notice that they will switch the variable back and forth to mess with us.
Oh, that's nice of them. The residual plot. We need to test for linear regression. To find the residuals in Excel, I need to copy and paste the dependent variable into the response variable. Oh, yeah.
All right.
Maybe I put these in wrong, backwards, like you were saying.
So, all right. Okay. So once the data are in, computer residuals for the data software. What's the best describe the residuals? So I'm just gonna do a max and a mean for the residual, and then it will tell us if the first option is there or not. So equal max.
Okay. Compute the residuals for the data using software standards. Oh. Who is the response variable? Independent. So what is our independent? Is that the score? I would say so.
Yeah, your independent is the score, and then your dependent is the one with a higher number.
Okay. Run that. Copy pasting your residuals will then be calculated in column E of the Excel spreadsheet. Okay, that's
Okay, so the first option, number 6, is wrong because the data are mainly between minus 38 and 24. So the next two options we have is the two bottom ones. So the residual form a linear pattern. The residuals are all negative. So, and the residuals are not all negative. So I'm thinking the middle answer should be the correct one. Let me know why you guys are calculating once together.
well, I agree with that. None of our graph is in the negatives in either axis. So, and the residuals are not between minus 40 and 25. There's some much higher. So,
so for number 5, what is that? Are we just looking at the plot of residual support? Because I'm looking at the notes and I can't quite understand what the heck.
Bartholomew thought it was the first one.
Guys, I'll be right back.
Okay, Bartholomew. Okay, so if you look normally distributed, like what are some of the things we can tell?
Well, you picked a bad time to leave. Okay. So 5, the residuals look normally distributed. 5 residual supports using linear regression when
A plot of residual support.
supports using linear regression. So we need to take a look at scatter plots in 3.1 for 16. Refer to as hot dog shape. There's no
Residual.
forward nonlinear.
No.
It's simply a visual check of the data.
We can Google this thing, right? Because sometimes when this is getting annoying, I can't find it in the book. It's like,
Yeah, Google's faster and better.
you know, that because we still have the exam review to do. So, and that's probably about 45 or 50 questions. I don't know how many they'll pull.
Yeah.
Yeah. That fun quiz.
Yeah, I'm really hoping I can score something on this one to get me, even if it's a B minus or something, man. I do not want to fail this class.
No way. I don't expect to get a B. Right now I'm in the C range.
Me too. Like I'm like lower C, and I'm really hoping to get up.
Got this. We gotta move on with our main project because we can't seem to get a response from the teacher. And I was gonna actually see if I could call him today if I could find that number.
Okay, because I emailed him. Yes, I think I CC you guys on it.
Yep, you did.
Okay.
Jeez. Okay, in 3.1 says to check requirement 1, we do two things. First, make sure to make a scatter plot and visually check to see if there is a linear relationship between X and Y. This is the hot dog shape. My requirements for a linear regression model. There's a linear relationship. The error is normally distributed. The variance of the error. I think he's getting his answer from number 3, from section 3.
Section. Which question are you
on? Section 3 of the textbook, and we're still looking at question 5.
Question 5. Okay, good. I kind of got lost there for a sec. Okay.
Sorry, guys. I'm
Residual
having
plot.
a whole lot of calls buzzing on me like that.
Right.
So you're still on question 5?
Well, we're just double checking it. So
okay. I think the 3.4.
3.
The QQ plot of the residuals.
A plot, but is there a plot and a QQ plot? Because if there are two different plots, then we could be looking at the wrong spot. Because it's scatter plot and a QQ plot, and the question is asking for a plot of residual. So which plot is it? Or is it just all plots? Or?
apply residuals using support.
Okay, yeah, we have there are several patterns that arise in a residual plot. We have the curvature outliers. Okay, just at the top of the 3.4.
Okay. Oh, okay. I guess you can only create a QQ plot for. Oh, actually, there's a residual plot and a QQ plot. I guess we can just continue with the test and come back to it once we answer everything and just do a try and error on that one.
Yeah, sure. Okay, so.
All right. So number 6 we got already. Number 7, based on the QQ plot for these residuals. So I guess the QQ plot is already done for us over there, I think, right? So that graph right down there is the QQ plot, right?
Mm-hmm.
Okay.
Yeah.
Look at curvature megaphone outliers.
What can you say about these residuals? Like how to tell if a residual is normally fairly normal, skew right. It kind of looks skewed right to me. I could be wrong. I don't know if it's my right or the computer's right or left.
Well, yeah, I suppose it's right skewed. I don't know, that would be.
Yeah, I did example.
It would be left skewed, right? Because wouldn't the collection where most of the data is, that would be where the higher percentages, and so the tail would be wherever the outliers are, the lower density of the dots.
Okay.
So I believe this would be left skewed. Except that's not an option.
Yeah.
Yeah.
Let's see. Residuals are clearly not normal. What makes the residual?
Around over here.
That's when they don't have any. Let's see.
Yeah.
Normal. Let me see.
I would say that they're not very normal. They don't follow a hot dog shape or nothing. Fairly normal. We've got the example of this somewhere.
Oh, okay, okay. So in 3.4, so in 3.4, it says if the points in the QQ plot are close to the line, then we conclude that the residuals are normally distributed. Well, oh, I guess we can put a line on it. Let's see.
Okay, so they're not normally distributed
Okay.
because they're not really close to a single line.
Yeah, they're all spread out. So they are not normal then? Well, let me go back to the note and see.
Fairly normal. Not normal. I would say bleh. My guess is the first one. The residuals are clearly not normal.
Okay.
It's kind of an educated guess.
Yeah, I mean, I'm kind of leaning towards that because they're not normal, and then the only option we have is if they're right skew, but I assume right skew would be a truckload of the data will be all on the right, but it doesn't quite look like that. They're kind of spread out.
Yeah, it is all spread out. It's not along a single line. Now, whether or not it's right skewed, I don't think that's true because it would be, if it was right skewed, we'd have a small collection of dots to the right of the high density area. So I don't think that's it either. So I think it's the first one.
Okay.
Use software to create a scatter plot of the data. Given the scatter plot residuals plot and the QQ plot, which of the 5 assumptions about linear regression are satisfied by this data?
Is there any structure in this note that says how to do this nonsense? Because I'm like, can't tell me to do all that one is not here. Okay, so let's see, scatter plot. Instruction here, open a content consider and click on the linear regression tab. Okay, linear regression tab, got that. I'm looking at section 3.2. And then it says, copy and paste the dependent variable. Okay, already did that and did that. Copy did that. Your residuals can be calculated in column E. All right, that's good. I already have that. Once you have already entered the explanatory response variable in the correlator, highlight both column D and E.
Okay, so we're insert scatter.
All right, so click on column E and D. And then it's sit on insert.
Why isn't this graph in here already? Then
Click on insert tab and then click on scatter. What the heck?
we're inputting our own scatter plot.
Huh?
We're putting in our own scatter plot.
Oh, insert. Oh, dang it.
to make a residual plot.
I don't understand this though. Like, click on insert tab. Oh, insert. There we go. And then hit insert scatter. Is that the first option? Holy scatter. All right. All right. So this scatter is right here. And then, so we have to do it for all three of them, right?
Hold on, I'm not there yet.
The question says scatter, residual, and QQ plot. So that's it.
Mommy says I can put it for me.
Close the door. Scatter with only numbers.
Is it? Do you know how to put QQ plot in this thing? Insert.
I'm not really sure if that first graph that was already in there, if that was a QQ plot or not.
It wasn't. So now we might have to revisit question 7.
All right.
But do you know how to put QQ plot in this thing? I totally forgot. Oh, scatter chart.
No. Well, there should be an insert button for it.
Okay. Oh, my Excel is crashing. Great. This is
Oh, good.
Maybe I should create a crashing plot first.
Yeah. Going up real fast.
I hate it when it does this. I'm really gonna need a new computer soon.
Come on, dude. Why is that red? I really need to know.
Oh my goodness, come on, not right now. This computer will give me a heart problem before it finally leaves.
And I understand.
Oh, dang it. I'm just gonna control this. Oh, here we go. More scatter plot. Come on, don't be sick. It's not QQ plot here.
They're crazy, man. They're crazy.
Well, at least we got a scatter plot. And we can look ahead and decide on question number 7. So, actually, question number 7 wants a QQ plot. Heck? Wait, didn't we have okay. Wait a second. The we had there was, let me see, it should be here.
Oh, we already have a QQ plot in one of the first ones.
Yeah, that's what I'm thinking. So if we can go to that QQ plot thing and just copy our data from here and paste it in there, it should create a QQ plot for us, right?
Yeah.
Okay, let me see. I forgot which book it was out of, or which.
That's the first unit.
Okay.
The
Is it
Quantitative, descriptive, and statistics.
okay? Descriptive. How to search it.
And I think we need to put in our residual. What does it say?
We need to put in a residual and explanatory, I think.
Okay, we need to put in the residuals for our QQ plot.
Okay. Oh, dang it. I don't think I have. I thought I had that. Descriptive.
Oh, wrong one.
It's quantitative, descriptive, statistic, right?
What do you mean?
It was the folder that we used to create a QQ plot. Quantitative, descriptive, statistic, I think.
Yeah, it is.
Okay. All right, there we go. And then I would just copy my residuals from over there and put it in here.
Mm-hmm.
Sweet. All right. And this class can be a joke sometimes. I won't lie to you.
I know. Sort column A from lowest to highest. Lowest.
All right, so do that and then sort, right? We have to sort from lowest to highest.
Yeah.
All right, let's see, sort.
Alignment. Where is the sorting button?
Oh, just highlight the entire column and then go to
Data.
yeah. Oh, there we go. Yeah, and then it will say sort from wait, A to Z is smallest to, and then Z to A is largest to smaller. There we go. Uh-oh.
No, it's good. We got it.
We got it. So this what?
Yeah, look at my screen.
Oh, okay. Let me there we go. Uh-oh. Oh. Whoa, how'd you? Oh, wait, you have, this is, wait, are we doing smallest to largest or largest to smallest?
Smallest to largest.
Oh, that's where I messed up. I did largest to smaller and it created an X. Let me go back there. There we go.
Well, look in the instructions right here. It says paste it in and then sort column A from lowest to highest.
Oh man, it is normal then. The QQ plus is normal. So then in this case, the residuals look normal in a QQ plot, eh?
Yeah, on number 7, they would be fairly normal.
Yeah, that's right. Whew. Man, I'm glad we created a QQ plot. And then question 8 is so we already got our scatter plot, we got our QQ plot, residual plots. Okay, no idea how the heck am I supposed to do a residual plot? Is it just this one right here?
Which one?
No. So that plot right there is not a residual plot. They created from the response and the explanatory variable. So we got to create a residual plot. Maybe I have to Google that.
Yeah, isn't that from our spreadsheet?
That the plot that the spreadsheet comes with, I don't think it is because it's using, if you click on it, it will tell you what data is selecting. If you click right in the center of the data, and it's just taking directly the response and the explanatory variable. It's not using the residual data at all.
Okay.
So, which of the 5 assumptions about linear regression are satisfied by this data? So there is a relationship between X and Y. I know that because the slope, my buddy told me, he said, if the slope is 0, then you have to do a lot of work. But if there is a slope, then there's a linear relationship. So there is a linear relationship between X and Y in the data that was given. The variance of the error term is constant for all X value. That's correct. The residuals are normally distributed, which we already did in a QQ plot by saying that it's fairly normal. The value of X are measured. Oh, you know what they're doing here?
What's that?
They're asking us here if we know the requirement. The question they're asking here is, does the data meet the requirement to use the linear regression? So if you look at a linear, the 5 assumptions for linear requirement, it's the same question they're asking here. Man, these guys know how to play fool out of people. Because that's just because I wrote it down yesterday. There are 5 requirements or 5 assumptions that must be met in order to do a simple linear regression. And these are all the 5 assumptions. So we have to select all of them, because if they don't meet 1 or 2 of these, assumption for us to do a linear regression.
Are you looking in section 3.5?
That's probably where I wrote it down on. I printed the homework out to work on it. So requirements. Yep, there it is.
Okay, what you hope to see, hot dog shape.
That's a relationship. The normal error term, there's constant variance, X are known constant, all in order to measure without error, and they're independent as well. Observation are independent.
Okay. Check each of the requirements above. So how many of these requirements have to apply?
5.
They all have to apply in order to check what?
In order to use a linear regression for the statistical data.
Okay. All 5 have to apply. So
the homework in question 1 of the homework, it says, what are the 5 assumptions to check in order to do inference for simple linear regression? How do we check for them? Answer this question by filling in. So that's how I just wrote it down. So there's a linear relationship. The error term is normally distributed. The variance of the error term is constant for all values of X. The X value are fixed and measured without error. Observation are independent. So just by looking there, we have 1. This is I'm in 3.5 again, the requirement. 1 is met. 5 is good. X are constant. And then the variance, I think the variance are constant as well, right here. Let me and another thing he also told me was, you see the R value?
maybe you should share your screen.
Oh, let me share. Okay. So something he mentioned was that because in this model, the closest R value is to 1, you know, the what is it? The relationship, they declare the relationship between X and Y. So if it was negative, then they really don't have anything in common. But if it's close to 1, then it's correlated. And here we have a 0.73. So it is closer to 1. That's what I'm assuming, that the variance of the term is constant for all value of x. And then the residuals are normally distributed based on our QQ plot, right?
We weren't real sure about that.
The QQ plot we drew, it was almost in straight line with the linear regression, right? Remember?
Yeah.
So that's our result. So that's the third option. So if we just do them one at a time, there's a relationship between x and y. This is option 1. Question 8, option 1. There's a relationship between x and y because we have a slope.
Okay.
So we check that one out. The variance of the error term is constant for all values of x.
Okay.
What he explained in this one, I'm trying to not butcher it. I think it was more like, how did you say? Like you don't get the same variance for different value of x. This thing is freezing on me again.
Well, you're thinking that the answer is the first, second, third, and fifth one?
I'm just going through them, checking them one at a time.
Yeah.
So the first 3, I know they're good. X is measured without error. I think I took a note on that, how to know if X, but we'll come back to that one. The 5th option says the observations are independent, and they are. In fact, they have to be before we can even use this. So the only one that I'm not sure of is the 4th option.
Okay. Well, in the book, it says the x's are fixed and measured without error. In other words, the x's can be considered as known constants. Not constant. iPhone and mega. Okay. Megaphone suggests that the variance of the error terms is not constant for all values of x. There are outliers in the residual plot that suggest that the error terms are not normally distributed.
Can you see my screen?
Yes.
Okay. So right here.
Number 3.
Yeah. So if these things are not met, in order to do hypothesis tests in a confidence interval using a regression line, we need to be sure that certain conditions are satisfied. There are 5 requirements for a linear regression model. So the way I'm taking this is, if these 5 are not met, we cannot do a linear regression. Does that make sense?
Yeah.
And if these 5 are what they're asking here in option 8, then all of them have to be met. Otherwise, we won't be using linear regression for this model. That's kind of the way I'm reasoning it, so to not confuse myself. So this is kind of like it's like a ticket for us to use the data that they gave us here to do a regression line. And if we don't have this ticket, in other words, if 1 or 2 of these are not met, we can use a regression line. But I could be wrong. That's just like the way I'm thinking about it.
Okay. Actually, I was measuring without error. Yeah, and you're totally right about that. The question we got to answer is, are the x values measured without error?
Mhm.
So we need to answer on number 4 that you got up on your screen there. We need to figure that one out, if that applies to our data.
Again, x can be considered as a known constant.
And how do we know if it's a known constant?
I'm gonna Google that one. How to tell if the value of x are known constant. Constant. Oh, and something that I was going to mention also is while we are doing this, so what we could do, because considering the time that we have right now, we can work on our project instead of doing the second quiz today, which is the 40 question. We can hold up that. I'll be meeting on my tutor throughout next week, and when we don't have Thursday, I can meet with him and we'll work through it, and I'll try to take better notes that I can just, I don't know, scan it and send it to you guys so that we can review it. So he and I get it done. I like send you guys a picture of it so you guys can work on it and get your answers too. And then when we can meet briefly just to go over the answer if you guys have questions or where, you know, where things didn't make sense. That way we can get it done faster, and we even have the sheet to refer to when we get stuck. That's just an option. Or we can kind of do try and error today, but with 45. I printed it out yesterday, and literally there are 43 questions on it.
Okay. Yeah, that sounds good to me. I'm
Okay.
fine with that. We haven't done anything on the project, mostly because of we haven't gotten feedback.
Okay. So if that's the case, then I guess once we get done with this, I'll probably head to the store and get some M&Ms and start collecting data, and then make the notes so that, you know.
Yeah. Yeah, I agree with that. We should do that. So after we're done with this, let's get this done so we can move on to the project.
Okay.
And we can get it started. So we'll finish this quick, okay, and then get our M&Ms.
Okay, give me 1 second. Let me make a note because I already printed a review out. Let me make a note on it that I need to get this done and send a picture to you guys. That way I don't just get it done and totally space out. So give me 1 second. Let me grab my pen.
Okay. It is B1. So. Slow. Okay. V1. Test. V1.
I'm gonna grab pen and you guys distracted me. All right. Okay.
Do we man, I can never remember this. So we reject when the null hypothesis, when the p-value is less than the level of confidence.
Mm-hmm.
That's great. Okay. All right. So this is what I'm finding for question 9.
Mm-hmm. So question 9, the slope is okay.
I'm seeing number 9 is 0.042.
Whoa.
Yeah, the same I got to.
Wait, okay. Can you guys share your screen with me, please?
Yeah. All right. So I'm looking right here on this line.
So you got to switch your response variable and your explanatory variable. So you got to put the x value to y and put y value to x. Because if you switch to the question, if you can switch to the quiz question,
Uh-huh.
I'll show you. Okay, go up to where it gave the data. I think that was in question 6. Okay, so it says use the confidence variable as the explanatory variable and the score variable for the response variable. So the score will be y, and the confidence variable will be x. To the data that you download. So yeah, so that
we should swap these.
yeah, because if you go to the data that you downloaded, the math efficacy, the data you downloaded, I can share my screen too.
Yeah, you should do that.
Okay.
Okay, let me share my screen real quick. Come on. Share. Okay. All right, let's see.
Score variable.
Almost there. Oh, there we go. Come over here. Okay, so the confidence rating here is these ones, right? So 4.43 and all that, and this is the score. On a question, it's saying explanatory. So the confidence variable is the explanatory variable, and the explanatory variable is x. So we come over here to the data. the confidence variable, which is this become X, and then this become Y, which it's kind of annoying. That's what I was talking about earlier. Like, what's the point of this? Why can't they just put this here and here so we can just copy the data at once? But they put X here and then put Y here so that we'll have to switch it around. And then if you don't get that right, every other question I thought it would come wrong. So, so the score variable here is Y, and then the confidence is X, because the question is saying that the score variable is the response variable, and that's Y. And then, does that make sense now?
Yeah.
Wow. So meaning we are doing the wrong thing all along.
Remember the last homework we did, the one that I sent the answers?
Yes.
That it was the same mistake that we made, and that's the only reason why I cut it. When I went to my tutor, I told him we did everything right, and then it took him a while to actually catch it. He said, with these, he took the class, he said, with these questions, you got to pay close attention, because it's easy to just copy and paste, but to make the thing harder, they will ask you to swap, you know, the variables around. So they will make they will put the response variable second and put the explanatory variable first, so that, you know, sometimes they will tell you to just, you know, use it as it is, or they will give these kind of, you know, unique instruction that if you don't catch it, you would just copy and paste and then go. So that was the only reason why I cut this, because this was only on the prep exam, the prep question.
Teachers are tricky.
Yeah, and that's what kind of frustrates me with this class sometimes, because it's more of, do you know how to take a test, and less of, do you understand the material.
I agree with that.
Yeah, so if you guys swap that around, your B1, well, mine B1 is 12.675.
I'm still not getting that.
You know, okay, let me
Are
see.
you looking at question 9?
Yeah, question 9.
Share a screen. Can you share a screen?
Yep. Wait, you guys want me to share my screen?
Yeah.
Okay.
Yeah.
Let's see. Okay. So let's go through the data and let me know whatever I did wrong here. Let me get this out. So right here, I have my explanatory variable, and you can just kind of look at your data also to see if I kind of did anything weird here.
No, it looks all right.
Okay. And then these are my response and everything. And I didn't change anything here. The only thing that if they ask a specific question will change is this, but we're not answering any question from here right now, so we can ignore this. So this is the slope right here.
Okay. Yeah, I'm getting 12.695.
So yeah, so that's our slope. That's question number 9 right there.
I thought you said 12.675.
Oh, sorry. Sorry, that was the test statistic that I did on another homework that I was just doing. Sorry, that was totally off. So I'm glad you guys were paying close attention and caught that. I would have put a random answer in a whole different.
You got my full attention. That's for sure. 14.715.
So that's B1. Now construct a 95% confidence interval for B1. And put your answer in the lower and upper bound. So an important thing, can you guys? Oh, my little cousin just said goodbye to her parents, and that's not going well.
Here.
So with the confidence interval on this one, even though it didn't write it there, we're always looking at the slope. The slope is where most of the line that the slope is on is where most of our answer will come from. So for my slope, the lower bound I'm getting 10.674, and my upper bound is 14.715.
Yeah.
So okay.
Yeah, I think that's what I have.
Okay.
So number 12, what I'm getting is that we failed to reject the null hypothesis because P is greater than the level of significance.
1 second, let me see.
On 12.
So p value has like a truckload of zero. So we failed. Oh wait, we reject. If it's less, we reject. If it's higher, we fail to reject.
Yeah, and isn't the p-value high?
No, it's less. So you see the minus 24 over there.
Uh-huh.
If you wait 1 second, I will do on my screen. Give me 1 second. So I will click here and watch what happened. Escape. So I'm gonna click that and
That would be 0.00 something.
yeah, it'll be like 0, 0. There'll be like a truckload of zero. So
Yeah.
I will do that.
Good catch, guys. Jeez.
So yeah, it'll just be so it's less. So we will reject.
Okay, so we reject because p-value is less than a.
Yeah.
Third option.
Okay. Reject.
Yeah.
Reject no because the p-value less than a. Yep.
Okay.
Then,
For 13, for hypothesis test will be 1. If you reject the null hypothesis, what does this mean?
Okay. It says that in a book on how to write our answer. 1 second. Let me save this. Okay. All right. Okay. No an alternative.
I never get this wording right. I'm not very good at story problems.
Let's see. There's an example somewhere here. I know we did it yesterday. Okay. There is sufficient evidence to suggest that there is a linear relationship between the head and the bottom. Okay, so that's if it's good, but if there is insufficient evidence, I want to see how to write it. We'll just put insufficient there.
So, wait, is there sufficient or insufficient?
There's insufficient evidence because we're rejected.
Okay. We rejected. So there's.
Oh, because it show. Oh, okay, guys. Can you see my screen?
Uh-huh.
So, so HOB1 is equal to 0. HAB1 is not equal to
0.
So in this case, there is insufficient evidence to conclude that the slope of regression line is not 0. What do you guys think?
We reject the null.
Because we're still referring to the slope and not it. Option 1 said there is insufficient evidence to conclude that the slope of the regression, but
We are rejecting the null. So if we reject the null, then we are.
it's
There is sufficient evidence.
so there's insufficient evidence to conclude that the slope of the regression line is not 0.
I would think that it is.
No, it should be sufficient rather, because when we reject the null, then it means that we have a sufficient evidence. Right? Then we have insufficient evidence.
Well, okay, let's go back to the example in this case. Where is it? The crocodile case in 4.1. Are you guys there?
Yeah.
Okay,
Yep.
so let's follow it closely and see. So that's the HOB1 and HAB1, and we will follow that and see what their conclusion was, and kind of how they word their answer. All right. Know that in the output, so oh yada yada yada. All right. We reject the null hypothesis since the p-value is less than the significance level. there is sufficient evidence. Okay, you're
Yes.
right, Bartholomew. There is sufficient evidence to suggest that there is a linear relationship between the hair. Okay, so that means it's not equal to 0. So there is sufficient evidence to conclude that the slope of the regression. No, there is sufficient evidence to conclude that the slope of the regression is not 0. Okay, so the fourth option, right?
I think so.
Yes.
That's what I'm going.
All right.
That's what I was thinking.
Sweet. I'm glad we can reason through this thing.
Yeah, we'll see if we get it.
Oh,
Okay, so we just got 5 more.
about it. Did we answer question number 8? I think I forgot to save it or something. Oh, yeah. I didn't save it.
Number 8.
Question number 5 is the only one we are yet to revisit. Why is she crying? Oh, okay.
Question number 8, I think we decided that 1, 2, 3, and 5 at least were needing to be checked. And then we weren't sure about 4.
Okay.
I went ahead and marked it.
Okay.
So I will submit and tell you what I get back from that.
So question number 14 is the body.
The crocodile one.
Are you guys there?
Yep, I got it.
Yep.
That's the body. And then oh, we gotta create a confidence interval.
Which variable is the dependent?
The dependent is the body.
Yeah. Body length. Now construct a 95% confidence interval for B1 and put your answers. And we are using dependent in the response variable.
Yeah. So in this case, it's just how it is. You notice how they didn't give specific instructions. So like here, once you determine the body length is the Y value, you would just copy them directly because the body length in this scenario is on the second column. So we can just copy both of them and paste them directly into the into the Excel.
Yeah, they weren't real clear on that. Which is the independent variable? Second, let me think about this. It seems to me like maybe the head length would be the dependent.
No, the head can't be because the body of the crocodile, the head determines what size the body is. That's what they're trying to determine here.
Okay.
Just think about it in this case, like the body function depends kind of on the brain. So if the brain is dead or the brain doesn't work in a way that the body will grow, the body won't go anywhere. So if we look into the spreadsheet that we downloaded itself. Let's see here. Measurement of the head length and the body of the just where is it? This let's go to the note in a book. I think a book would be really useful in this case. Crocodile.
I looking at 4.1.
Yeah. Okay. We want to know if there is a linear relationship between x and y for the yada. I freaking hate it when it is. Usually they will give a little note on
So the dependent variable is the body length.
Yeah,
is the body.
Yeah, that's
When you look at that, the 4.1
4.1 right below the ANOVA.
under that table.
Yeah.
It's a the dependent variable equal to the body length.
Yeah. So question number 14 is the second option.
Yeah.
And then with that in mind, we can just paste our value for them.
So that's all really going.
All right. Okay. 25% confidence interval. I'm getting 7.218 and 8.103.
Yeah.
The margin of error. Sorry. Whoa. Pause. I was thinking about the interval, but question 15 is asking for the margin of error.
Yeah, I assumed you were talking about 16, 17. But
so are we gonna do that thingy again?
I don't know, man. I always get the margin of error wrong. Don't ask me.
I think so. What I'm gonna do is I'm gonna get it the absolute value. Let's see.
Yeah.
I always get the margin of error wrong every time.
Let's see. I think
so the white never gets on. Never gets on.
Let's see. Okay, I'm gonna plus the upper bound. I can't remember. Let's see. Okay. So the first one, the last time we did it, I did plus and it came out right. So equal ABS value of this plus ABS this. Yeah. All right. I want to do C plus or minus. I need to check in one of my old file real quick to see what last formula I used. Give me 1 second. Absolute value. Where are you? Oh, there we go. Oh, okay. Guys, I think we're gonna get it right. All right, there we go.
You got this.
Almost there.
You got this.
About 2. Okay. I'll share my screen with you guys real quick. I'm almost certain that this should be good. Let me share my screen with you guys real quick. Okay. So let me know if you guys can see my screen.
Yep, we can see.
All right. So just to double check, I imported. This is my data that I imported, and all the way down to here. These are my explanatory residuals over here. If things seem out of place, let me know. And then 95% confidence interval. Whew, man,
I think I also got the same thing.
Okay, they're almost correlated. All right, so I came down here, everything's good. So for the confidence interval, this is my margin of error. So since this is the confidence interval, I'm using this bottom one because it's again always the slope. So I took the absolute value of the lower bound plus the absolute value of the upper bound, put both of them in a parenthesis to make sure that it adds them first, and then I divided by 2. And this is what I got. So I will submit, once we get our submit first, but we've done this before. This is kind of like what you did, Justin. I think the only thing that I think I was getting wrong was I will put minus here. I will subtract the lower from the upper, but I just add both of them and then divide them by 2. So that's what I did. And I'm gonna put that 7.660 in there and cross my finger.
Hold on. That doesn't look quite right. Let me look at your formula just a second.
Okay.
14.
So I don't know if I'm supposed to do the higher plus the lower, but if I even do higher and lower, lower and higher, they always come at the same step.
You need to subtract, not add them together.
The last time I subtracted though, it came off wrong.
Yeah.
So in this case,
if it I don't know if
we
it's
add the 2 and divide it by 2.
That's what I did. So I was going to ask you guys last time. So I don't know if it's appropriate to subtract if one of the value have negative or they both have positive, or if it's okay to add if they both have how do you call it? If they both have positive value. The last time I did this, however, I added them. One of them had a negative value and one of them had a positive value, and the answer came out correct somehow. I don't know if that was coincidentally because the value got there. That's the only reason why I did this. But I guess I'm willing to submit first if that's all right. But if you guys come up with another number that's so different, we can try that number too.
No, let me try it.
Okay.
I'll submit. Okay, you guys.
Okay. Wait. You have you done the lower and upper bound yet?
Yeah, I've done them.
Whoa.
7.218 and 8.103.
Okay. And then for question 18, what you put?
I haven't put anything yet. Based on your lower and upper bound from the last 2 problems, what can you say about B1? This is another one of those wording problems that I'm not good at. So
B1 is the slope. Oh my goodness. You guys notice something? So the margin of error that I calculated is the same as the slope.
Oh, hey, how about that?
You notice that? So I don't know if that's a good thing or a bad thing.
I think it's a bad thing. I don't know though.
It seems I'm getting a different confidence interval from you guys.
Actually, the first option seems correct to me.
What confidence interval are you getting?
My confidence interval was 7.218 and 8.103, and the margin of error 7.66 or the slope 7.66 can be found between the confidence interval. So I'm thinking question 18, first option should be good.
Well, because I'm getting 0.567 and 7.753.
For your confidence interval?
Yeah, because the model summary, I think I have the same thing with you.
Could you share your screen, please?
Okay. Can you see this here, right here?
Yeah.
So I don't know.
That's okay. So go back to your data. I think you just paste your data directly. Try pasting your data as a value. You notice how the lines are all gone. So try repasting your data in there And then scroll down a little bit. Let me see the bottom of your data. Go back up.
Did you delete all of your previous data?
Yes.
Okay. So then I guess the only suggestion I would say in this case is to
Let me redo it and see.
yeah. Yeah. So just but hit Control Z there though. I would say hit Control Z to take it back to the norm because right now it.
Okay.
Because Justin, you got 7.218 and 8.103, right?
Yep.
Okay, so I'm thinking it's a pasting error. Maybe he pasted it wrong or something.
Yeah. Uko, what do you think 18 is?
I think 18 is the first option.
Okay.
Because we never say chance, you know, when we're giving when we're giving that. There's like we don't ever say chance, so we're confident that.
Whoa! I got the margin of error right. Holy cow!
What was it?
0.442.
You.
I never
All right.
get that right. Ever,
Wait,
ever, never.
So what was your calculation?
The calculation was, I will share my screen because that'll be easier.
Oh.
No, wrong screen. All right, so what I did was, here's my calculation, all right?
All right, so let's see, L14 minus, oh, so you subtracted.
Yep, so I did what you did, but I subtracted.
Okay, I guess my question is, maybe this might help us discover something. I think if they are both positive, you subtract. If one of them, if the lower bound is negative, you add.
Well, as far as I can tell, what you're trying to figure out is the distance between the lower bound and the upper bound. So it depends. If your lower bound is in the negative, then you need the absolute value of it.
So if they're both positive, you won't need positive. You won't need an absolute value then.
No, because
okay,
that doesn't do anything.
That makes a lot of sense. I got to write that down because I think that will be really helpful. In the long, I'll make a note of that.
So I did so you're just trying to find how far apart the lower bound and upper bound are from each other. You do that from by and then you divide that number by 2, and that's what my second column is.
And I will put a note in the like before. So I would just write a note here that if both values are positive, this is the margin of error. If the lower value is negative, or if one of them are negative, you get the absolute value. Do you subtract still, or if one of them is negative?
What, I couldn't quite hear you. What was your question again?
So let's see if the lower bound in this case, if it was a negative value, will you get the absolute value of both of them and subtract the upper bound from the lower bound and divide by 2? Like what would you do if one of them was negative?
You would take the absolute value of both and then subtract.
And subtract, okay.
And then divide by 2.
Okay, I'm gonna make note of that right here. This is margin of error. Both upper and lower. because this is one thing we always struggle with. I just want to make the note now, since I think we made a breakthrough here.
Yeah.
We get it.
I always struggle at it. I always get that wrong. I can't believe I got it right.
Okay, good. All right, and then I'll make another one here that will do the absolute value, and then I'll put a note on it too.
Yeah.
So other than that, we got everything else right?
Not quite. We got stuff right that we thought would be wrong, but we got wrong things we thought would be right.
Dang it. Hit it when I hit it.
I know. So we got wrong number 8 and number 6.
Give me 1 second. Let me write my notes in this sheet, and then I will run to number 8 real quick.
All right.
Oh my goodness. You won't believe what I just noticed. Okay, I got to share my screen. Maybe this will help hammer down this concept that you just discovered. This is a big breakthrough. I got to. Okay.
All right.
Can you guys see my screen?
Yep.
See what just happened, okay? So your theory is perfect. So over here, I did the absolute value of this minus this divided by 2. And you see my answer? And then I came up here and did this minus this divided by 2 and got the same answer. So your theory is right. So let's say if this was in a negative and both margin of error will be correct, you know, depending. So the formula you just came up with is the legit formula. If we use that, always will come out right.
It should. Yeah, in theory. Yeah.
Because I did it both the absolute and regular, and we still got the same answer. So that's good. That's good. That's some good stuff. Thank you.
Hopefully it works.
I'll save that. Okay, so you said question number 8.
Number 8, number 6. Unfortunately, 8 didn't give us.
Okay. Number 8 is select all.
I did click all of them.
And it said it was wrong.
Yep. So my best theory is that number 4 is not part of the ones that should be checked.
Okay. I will take that out when I submit. And you said number 6. Number 6 is the middle one, and it said we're wrong.
It's not the middle
one.
It is not the middle one.
They're not gonna piss me off because if we pick one, I mean, they're clearly not between negative 40 and 25. You see what I mean? Like I've done the minimum and maximum, and they're not.
Yeah.
Well, I guess wait, pause. I might be misreading it. It said it's between.
Between. So is it less than? Okay. Is all the data points between that minus 40 and 25? What's the minimum and what's the maximum?
The first option is correct. What I got wrong was I was thinking the other way around, that it will be negative. So I'm gonna do minimum and maximum real quick. Equal MIN.
Yeah, find the minimum and then find the max if they are if they're between those two numbers. Okay.
Because the minimum is minus 38 and the minimum here is 40. So 38 is between. Oh my god, I can't believe I messed that one up.
Well, where's the max? Find the max.
The max is 23. Someone to give me 1 second. Almost there. Oh, this thing go for it. There you go. All right. So the max is 23.4 and the mean is 38.1. So first option will make sense.
Yep, first option.
The first option.
Yeah, first option. That's right.
And then number 8.
You were
Okay,
pretty sure about the first 3.
So number 8, the first 3 is good. And
So let me also submit my own.
So number 8, what do you have? So go through your answers. Let's make sure that we are kind of on the same page, and then before you submit, that way we won't repeat the same mistake. So number 3, but Bartholomew, what do you have for number 3? Number 3 is the third option.
Yes.
Number 4 is the third option.
Yeah.
Yes.
And then number 5, what do you have?
First.
Number 6 is first option. We just corrected that.
Yeah.
Number 7 is the middle option.
Yeah.
And number 8, what do you have, Bartholomew?
I have the first, third, and the first, second, and third, and the last one.
Okay, so number 4 is out. That's what Justin is suggesting too. Okay, good. And then number 9, you got 12.695.
Yep.
Number 10, 10.674.
Yep.
Number 11, 14.715.
Yep.
Number 12 is the third option.
Yep.
Number 13, the last option.
Yeah.
Number 14, second option.
Yeah.
Number 15 would be 0.442, right?
Yep.
And then number 16 is 7.218.
Yep.
And number 8 is 8.103.
Yep.
And then just a quick question of Bartholomew. So when you repasted your data value, did it work out this time? What do you have for 16 and 17, Bartholomew?
My Excel is just crashed up. I'm trying to do that one. So I'm still. I'll check it out.
So then let me go ahead and submit then, since you're still.
But since Justin has got it right, I think we can let you submit it.
So 18 is the first one. Just clarify.
So 18 is the first one. So you want me to submit, or are you going to submit?
I'm going to submit.
Okay. And I'll just submit. I think we got everything right. I'm just submitting.
I got question 8 wrong.
Again.
Not surprised.
Yeah. Yeah. So I think we have to go back to the book again and read that summary, the requirement.
Okay. So I'm going to remove the second option and submit.
Okay.
So right now we have. So we have I have option 1, option 3, 4, and 5. Okay.
All right.
All right. Where are you? Oh, damn.
Sorry, I can't. There you go.
So, you guys gonna put some effort in our group project? Or do we even need to do anything in a group project other than go and get our data?
I don't know. Take a look at it. What did you get for question?
I got it wrong. So I got it wrong. So number 8 is the only wrong one that we got. Otherwise, everything else was like perfect.
All right. So let's move on to our project then.
Yeah, that's because it's just one question that we're getting wrong here, and I don't know if it's worth our time.
Yeah. All right. So we need to take a look at the previous week. So we actually need to go to lesson week 11, collect and describe the data. Begin working and collect and describe the data and describe the data in your study. Top projects. All right. Did Bartholomew disappear?
He's uh-oh.
Justin, I'm around.
Oh, okay. Okay.
Okay. Now then, I'm going to share my screen and we can all look at the same thing.
Okay.
Okay.
Document, open up. There it is. Project, group name or number. We are group 5, right?
I think so.
The name. Go. School's almost over, guys. Just almost there. Okay, we're going to restate our question. Okay, so our question was, are there more yellow M&Ms, yellow peanut M&Ms, because that's Buko's favorite.
Actually, I was thinking about that question. That I would just throw an idea out real quick. Would it be appropriate or even more concise to say, are all the yellow M&M peanut in each packet the same amount? Or this is still good? Because thinking if there's more, I guess they're the same. I was just thinking about it last time. Like, should we say, are all the yellow M&M in every M&M bag the same? Like, are they the same or they are not the same? Then our hypothesis would be HO equal the same or HO equal not the same. You know what I mean?
Yeah. Is it not
That's
equal?
yeah, that's either equal to or not equal to. That was just a thought, just if that will make things a little simpler.
Perhaps.
But
It might. We could just ask the question: is there more of a certain color of M&Ms than there are of others? We don't have to be specific on the color.
the only reason why I'm thinking to be specific is it narrows down how many data we'll be focusing on. Whereas, because if we're putting multiple colors, then I'm thinking, I don't know, ANOVA or like, several.
Yeah, true.
Yeah, right. If it's just one, like if we're just looking at one M&M bag, one M&M color, then we're just how many yellow are in bag 1, how many yellow are in bag 2, how many yellow are in bag 3, and then it's just that same color. Then we'll ignore all the other colors. But just a thought.
Whatever we can do to make it simpler. We don't want to complicate things because we don't want to be rejected on our study.
That's true.
So we should go the simpler route.
Okay. So should we keep the are there more yellow M&M or are all the M&M the yellow M&M in every bag the same? Like which one would be a little more precise or
Are there more yellow M&Ms on average? Are there more yellow?
More yellow M&Ms will be better.
okay. What do you think?
Are there more yellow peanut M&Ms in my bags and other colors? That's data collected. Okay. So, all right. So then we just need to collect our data, and let's go to the next lesson.